Hello everyone, I hope you enjoyed this DevCon and welcome to my talk, CSS Flicks, Creating Video Experiences with Algolia. My name is Bonomi. I'm a senior DevRel engineer here at Algolia and I've been working at Algolia for almost 9 years now. I used to be front-end working in an engineering team at Algolia, but recently I switched to the DevRel side of things. You can find me online with my handle LuckyVG, which is the one I'm using pretty much everywhere on the internet. So a little of background about me. I love CSS. I really love CSS. It's an amazing language that can allow you to do pretty much crazy stuff. You can push the boundaries of this language to create crazy experiments, or at least that's what I do. I love CSS and I love Algolia. I love CSS and Algolia. These both tools allow me to create cool demos like the one I'm going to show you today. I love CSS so much that you can find hundreds of demos on my CodePen account. So here it's buttons, but I create demos for a lot of different topics. I recreate designs. I push the CSS language to the maximum, and I try to play as much with it as I can. I create a lot of different websites, like this one that reference cool buttons, and this website is actually called buttons.cool. It's an Algolia experience, so all these buttons are from CodePen and hosted on Algolia, and you can visit the website and you will find hundreds of different buttons with cool effect made by super talented people. I also create demos for Algolia. Here, it's a site that looks like Netflix. It's actually called the Spooky Movie Search, and it references a lot of spooky movies that you can filter by your genre, actors, and directors, and find inspiration for your next spooky movie night. You can find a lot of experiment on my website, experiment projects, tiny details. I love working with SVG as well. It will give you a sense of like what I like to do on the web, experimenting and making cool demos. I also love working on fan websites. So this is a website I did for for a video game I really like. You can use it as a tool to help you during your journey on this game, and it's a website that I had a lot of fun creating the design for. Yeah, so it gives you a little bit of overview of what I can do and how I find the web playful. So today I'm going to show you something cool. So this is the demo of the day, AlgoFlix. So first you start by giving your video a title. Hello DevCon 2024. Yay. Turn on the webcam. Hello. Click record. Little happy dance. Thumbs up. Woohoo! And the Algolia logo. Now that it's done, you click send to Algolia, it's sending, video index successfully, which means that the background script finished working. You click on view all, and now you have the video. It's a video clip containing 100 frames. You can play it. Here's my little happy dance, my thumbs up, and my attempt to capture the logo, which was questionable. You can pause it, you can traverse the hits, visit different hits, and play the video backwards with the range. You can stop it and play it again. So yeah, it's just a small clip. It was cool, wasn't it? So now I'm gonna tell you how I did this small demo. So first of all, why did I do this? So you have to know that I love working with Pixel. I really love working with Pixel, I love working with CSS, and I love working with Algolia. And with the three things in mind, I will explain you how I use box shadows to make these videos. So if you're not aware, this is a basic box shadow. A box shadow is basically a way in CSS to create a shadow for a box or for a shape. Here it's a basic box using a basic box shadow, 0 pixel on the x-axis, 10 pixel on the y-axis from top, and 16 pixel blur, and then there's the color. You can use box shadows for different purposes. Here is it's another basic box shadow, but this time it's a replica of the main box that I put on the side with 10 pixel gutter. So you can see 410 pixel on the left, 0 pixel on the y-axis, 0 pixel blur, and boom, it's a box. It's basically a pixel. Pushing this, you can do cool stuff with box shadows, like these crazy trippy artworks that uses box shadows and some math formulas to create these colorful artworks. You can play around with it. It's on my CodePen. Just look for Shadow Vision or CSS Paint API, and you will end up on this experiment where I manipulate box shadows to create cool visuals. Talking about pixels, this might look familiar to you. It's an experiment from Reddit. I think this one was from 2022. It's a collaborative canvas where people could go and color the canvas all together to create a collaborative artwork. I took part of it and I really loved it, which made me think that I could probably replicate something similar with Algolia. So what you can see on the left is actually the Algolia canvas, where a lot of people came through during DevCon 2023 and drew different artworks together. We could be at the same time, like it was really cool to see the artwork getting drawn simultaneously. So there were a lot of people were playing with this artwork live, and it was really cool. I wrote a blog post about it. Go on our blog, look for our place, and you will end up on my blog. On my blog post, sorry. So why did I do this? Mainly for fun. I love using CSS to make fun things. I love using tech to for unexpected purposes, like these chairs using Vespa motorbikes that are then turned into chairs. A Vespa motorbike is not initially meant to be a chair, but here it is. And that's why I like the web. It's because you can take a piece of tech, bend it to make it do what you want it to do, like I did with this canvas. I used the Algolia engine to create a collaborative drawing canvas, which is not what Algolia is meant to do in the first place. You can go check it at algolia-canvas.versal.app, and you can draw a few things on it. It's really fun. As per my demo, how does it work? So you've seen it all starts with a webcam. The webcam sends the webcam feed to a canvas. The canvas uses an algorithm that gets the dominant color of a given space, so it's bigger pixels for efficiency purposes, and then the canvas returns an array of colors that I can use to generate a box shadow. A frame like this on the left is actually made with thousands of shadows, using only one box shadow and thousands of shadows, one next to each other. You line up the squares and boom, you have a frame. In reality, a frame looks like this. The more you zoom in, the more you realize what you see is actually HTML colors that represent my face here. I just removed the hash sign for reading purposes. So that's a frame. How do I make a frame? A frame is a snapshot of the canvas that is returned as an array of color, as I've explained earlier. So this is an example of a simple array of color, but in reality looks like this. And the more you zoom in, the more you realize that it's different color values. Then I capture a lot of frames. So here from the frame 0 to the frame 24, I capture a lot of frames, and then I can play them one after the other. And that's what makes the video. So some basic math right now. I want a 10-second video with 10 frames per second. So it's a total of 100 frames. Super simple, easy to understand. Here's how a frame looks like when it's stored in an array, when it's getting out of the canvas, and this is the material I use to work with. And then I pass this through a function that creates a box shadow. But you might wonder, what's the role in Algolia in all of this? Well, every frame is then stored as a record. So my 100 frames are equivalent to a 100 record. Let's split it up and let's dive in to understand how it works. This is the type of a frame. The first attribute is the frame number, which is the ID of the frame from 0 to X. Then you have colors, which is the actual array of colors. Then the object ID, which is a mandatory attribute for Algolia. And then you have the title, which is the title given to the small video clip. When I click record, what happens is that the script will snapshot the color array 10 times per second. So every 10 times per second, it will get the value of the canvas, turn it into an array, and store it in a bigger array called the matrix array, which in the end will contain my 100 frames. When I click send to Algolia, an asynchronous function will create a temporary object called the temp body containing all the data, so my 100 frames, and the title of the video. And then it will be sent to my API route as a JSON string. When the API route receives the data, what it actually does, it will iterate over. So remember, data is a big array containing smaller arrays. So data, you can iterate over it, and for each array, I will create a record with the index number being the number, the frame ID, so 0 to n, and colors being the actual array of color representing my snapshot, my frame. And then I use the method save object to send the data to Algolia. And when this is done, eventually I will see this on my dashboard, which is a regular view of the dashboard. So these are actually my frames stored into Algolia. So now that it's done, it's time to retrieve the frames. To retrieve the frames, I use the method search for facet values. I target my index, and then I target the title, which is the facet name that interests me. So I use the title as a filter. Then, when I get all my facets, so all my video titles, all my clips, I iterate over the facet values, and I use a load video component, which is a React component I wrote, to retrieve all the frames that matches this title. So remember, every frame's got the same title because it's the same video. So for this, I use the search single index method, which targets my index, filters per title, and get all the hits. So the max frames is equivalent to 100, and then when I get all the hits matching my filter, so my title, I set them in a state called all frames. So all frames eventually will end up getting my 100 frames. And then when I have all my frames, I can use the current frame, which is the number n that I want. In my demo, it will be 0. So all frames, 0, and then I get the colors, and it goes through a shadow function. The shadow function actually will split up the array, and given a few options, will find the correct position for each pixels on the x and y axis. The first condition is here to fill the first pixel, which is an inset shadow, because remember, box shadow only replicate the shape of the initial box. So the first, if the index is 0, it means that the position needs to be within the div representing a pixel. But this was a little hard for the browser to use, so I needed to find improvements to allow the browser to replay my videos in an efficient way. So I removed the 6-digit hexadecimal. As you've seen, it's only 3-digit hexadecimal I'm using. I use Q instead of PX. q being a unit, a shorter unit than px, that I can use. Instead of saying 0 pixel 0 pixel, it's 0q 0q. And I remove all the unnecessary px occurrences. So in the end, my function will look like this. It will return values without px and with plain zero, because a zero doesn't need a px value to work. So this, for the browser, turn into this, which multiplied by 1,000 is a lot of bytes saved, and then the browser will not crash, and you can play the video back and forth, and you can load a lot more videos than if I kept the initial syntax containing a lot of extra characters. So thank you for listening to me. My name is Luca Bonomi. We will put in the chat the URL of the demo, so that you can play around with it and maybe record your own videos. And I hope you will enjoy the rest of the DevCon. Thank you.